You've probably noticed that the weather changes at different times of the year because the seasons change. However, we may not always think about what causes different seasons. Today, as we dive into our studies of space, we're going to discuss how the Earth's orbit around the Sun and the tilt of the Earth impacts Earth's seasons. First, let's think about Earth as a planet. Sometimes we do not realize that Earth, the planet we live on, is a ball of atoms held together by gravity, like the other planets in our solar system. Earth is a terrestrial planet, meaning that the surface of Earth is made up of compact rocks. To complete one revolution around the Sun, it takes Earth 365 days, 5 hours, 59 minutes, and 16 seconds. Because it takes a bit over 365 days to circle the Sun every 4 years, we add a 29th day to February so that our seasons fall at the same time every year. While a revolution is the amount of time it takes for a planet to orbit the Sun, a rotation is the length of time it takes a planet to complete one spin on its axis. An axis can be thought of as an invisible line going through the center of Earth from one pole to the other. Around this imaginary line, the Earth spins. It takes Earth about 24 hours to complete one rotation, and we call this length of time a day. Now, there are two different ways of thinking about Earth in days. A solar day is the length of time it takes for the Sun to pass over a specific point on Earth's surface, and a solar day is measured relative to the Sun. In comparison, a sidereal day is measured relative to the stars. Since the Earth is revolving around the Sun at the same time as it is rotating around its axis, when the Earth has completed one rotation, the Sun is not quite in the same position as it was the previous day. Therefore, a sidereal day is the time to complete one rotation, while a solar day is one rotation plus a bit more to line the Earth up with the Sun. You might be wondering what all this has to do with the seasons. We've discussed Earth's axis a bit. Another interesting point about the axis is that it's tilted 23.5 degrees and it always points the same direction in space. The tilt of the Earth plays a crucial role in creating Earth's seasons. Let's use some paper and pencils to draw a diagram of Earth and the Sun. First, let's draw the Sun, the source of heat and sunlight. Then, let's draw the Earth and make a line to show the axis. In June and July, the North Pole is tipped toward the Sun, making it summer in the Northern Hemisphere. Half a year later, in December and January, the North Pole is tilted away from the Sun, causing summer in the Southern Hemisphere. Due to the tilt and curvature of the Earth, the sunlight is less intense at the poles of the Earth at certain times of the year. If you have a ball and a flashlight that emits a round beam of light, you can experiment with how this works. In a dark room, turn on the flashlight and shine it at the ball. You will see a circle of light on the surface of the ball. If you move the flashlight up or down, the circle becomes more elliptical, and the light is spread over more space. Let's go back to our diagram of Earth and the Sun. When the Sun is the furthest away from the equator, a solstice occurs. There are summer and winter solstices. The summer solstice is the day with the most daylight in the whole year, while the winter solstice is the day with the least amount of sunlight. There is much more to discover about how Earth interacts with the Sun and space, but understanding the tilt of Earth's axis and how the seasons are formed is one of the first steps in discovering the magnificence of the world above us.
Bingo